So yeah, we're going to be talking about the automated conversion from Flash to HTML5. You heard the condensed version of this from Andre earlier, and we're going to be talking about this and the details. My name is Keshav. You'll be hearing afterwards from Nenad and Ricardo, and we're all software devs or game developers at InnoGames in Hamburg with the Forge of Empires team. Yeah, we're going to be, so the agenda for today is this introduction of what we're doing, why we're doing it, and what went into the research before we actually started implementing this solution that we needed. Implementation, including some details, and Nenad and Ricardo will be talking to you about this. The current state of where we are as a project, and in the end we'll have a live demo. We should also have some time for questions and answers at the end. Yeah, so as an introduction, let's see. So first of all, we are InnoGames. You've heard most of this before. We're one of the largest game developers in Germany. We have studios in Hamburg and Düsseldorf, 400 plus employees, revenue of 130 million euro in 2016, and we have 6 live games portfolio. I think you saw some of that from Andre's slides earlier. And the game that we are working on is called Forge of Empires. It's a city building strategy game. It's Flash based. We also have mobile clients. It's a fairly large game. It's been around for a while, and it's earned InnoGames quite a lot of money. Yeah, it was released in 2012, and we have a fairly old code base, or not old, but 6 years old code base. And we have, yeah, like I said earlier, mobile versions available on various platforms. We continue to release new features and content very regularly. We have a release cycle of 2 weeks, so every 2 weeks players see hopefully something new, and this is something we want to keep even with the new HTML5 project ongoing. The features in the game. Let's just take a quick look at the game so we know like what the game looks like and what it should look like once you're done converting. It's a city builder, so this is your city. You have a ton of really cool buildings and animations. You've got, depending on the age you're in, you have inhabitants and like cars and stuff driving around the streets, or in this case the water streets, and like drones flying around your city. We have a research tree where you actually go through the ages, and yeah, you basically progress through the game here. We have several, well, not several, we have 2 multiplayer features where you can play together with other people in your clan or guild. This one is called Guild Expeditions. It's one of our newest big features. We have a strategic battle, which is like one of the core parts of the game, where you either fight against other players' armies or you fight against what's it called, PVC, so against the computer. And yeah, you have a single player campaign map, which you have to, like, you can conquer different provinces and win rewards and so on. This is Guild versus Guild. It's also another large feature that's a multiplayer feature where your guild tries to conquer sectors from or areas from other guilds. Yeah, this slide is to be repeated because yeah, it is what it is. So Flash player was going to die. We knew that quite some time ago. Didn't know when, like everybody was saying, but we knew we had to do something about it. And so yeah, so we need an alternative to our Flash games, and this is why we are here, and this is why we took up Hex and OpenFL. But before that, we basically, since we're not going to have Flash around forever, we had to find a solution, and we had to find a solution, and we set ourselves these parameters. We definitely didn't want a feature freeze. We wanted to continue developing while we do this project on the side, which means our client teams are still like we had divided up into a team that concentrates on porting the game to HTML5, and the rest of the team actually still delivers content and updates and features to the actual game in ActionScript. We don't want to rewrite the game because it's going to take too long, and we already did that once for the mobile ports a long time ago, and it wasn't a great solution. It's improving now, though. We want to prefer automation as much as possible in every place that we can. It just makes it makes the first part so much easier. It would, in an ideal world, we just have one button, we click it, and voila, we have a HTML5 version. We want to do it in a reasonable amount of time because, like, Chrome is going to, well, actually all the browsers are going to still flash very soon. And we really got to be careful with the risks that we take. We have like a good handle on risk management in general. Make sure that we don't do stuff that can basically mess with the features that we are developing right now. And after all this, if we can, and we should, we want to have good performance on the HTML5 target. And this is also something we have to take a look at. So initially we set about how we did this was we had to research several options. And before the research, our status was we have a successful game, large player base. We have 4,000 plus, more than 4,000 classes of game code only, not including libraries and so on. We have quite a lot of legacy code. We also have very strict coding guidelines, which we've managed to keep over the years, which is a really good thing for us. Our assets, we use SWF asset bundles, and we use a lot of libraries, including Starling and extensions, robot legs, MEC framework and extensions, and some tween engines, particle engines, and other internal and external libraries like translations and sockets and so on. Right. So initially we took a look at what options we had. What could we even use to do this porting, and these were a list of what we came up with: Hex and OpenFL, TypeScript with the Egret engine, a web export from a mobile client, which, we'll come to that in a bit. Dart with Stage Excel, which was new at the time, and rewrite of the game in Unity, which didn't really go with our philosophy of no rewrites, and using an ActionScript to JavaScript converter. There were a few options there, but yeah. So we took a look at these. Within the limitations that we'd set ourselves, the constraints that we had, Hex and OpenFL looked like it was going to be feasible. TypeScript and Egret also looked like it would be feasible. The web export didn't, because the export from Coco Studio wasn't so good. Like I said, Stage Excel was new at the time, so Dart and Stage Excel didn't look like an option for us. Unity rewrite was against our objectives completely, plus also the Unity web export. Well, at that time the plugin itself was going to be deprecated, and the export itself isn't mature right now. And there are several converters, AS3 to JavaScript, but none of them were really feasible for a large project like ours. So we had these two possibilities, and we thought we needed to prototype these. The idea basically was to test the limitation, find out if there are going to be any limitations, any technological issues or things that are going to block us, basically. And we wanted to test the foundation blocks of our game, which were three things. One was the Starling layer, which is the GPU accelerated rendering that we use in the city. We use in a couple of modules, like the two multiplayer modules we talked about earlier. And we wanted to test this with like a larger than normal city. This 166 buildings is more than any player can have. And with animations, with the depth sorter running, so we can really test it with to see if performance is going to be a problem. The other rendering part is the stuff that we render the UI in on the DOM layer. The DOM rendering. This is the game HUD on top of the city. This is all our windows, the pop-ups, tooltips, stuff like that is all on this. And we also wanted to see if we could, in the prototypes, have a quick backend communication, because a lot of our game logic is in the backend. So we created these two prototypes in Hex with OpenFL and TypeScript and Egret. They were both similar in features. They actually fulfill the requirements, and we gathered a bunch of metrics for FPS, CPU, and memory. This is the orange one, in case you're wondering, is Hex. In general, it performed better than TypeScript in most cases. So that was a good initial indicator. This is what our prototype looked like. A lot of buildings with a lot of animation. We actually had fairly good FPS up there. We have so this is the styling layer in the city. We have a UI layer here and the top thing there, and probably also this beach ball. So this was a running prototype that we delivered fairly early. So we needed to make a decision at this point, and we considered all the metrics that we'd gathered from these two prototypes. We also had to consider that the code quality from the converters, the converter from the Hex Foundation, basically the quality of the Hex code that was generated was better than the one from the Egret converter. This was a really important, really helpful for making the decision, because it's open source stuff. I mean, it's really easy to be able to extend this towards automation, which was also another big part that we wanted. So easier to automate because of open source, and this way we can have parallel development of features from the other guys in the team. And we basically didn't see any very obvious or very clear advantages from TypeScript and Egret. So at this point we decided that we're going to use Hex, OpenFL, and we're going to use this as our mid-layer porting technology. We'll next be talking about the implementation of what we did and how we did it. Ricardo first will be talking about this stuff, and then Nenad.
So let's get on with it. So when after the research, we went to implementation, and we set the first milestone, which was figuring out the math from the prototypes, and we set two objectives. Basically, have 0 compilation errors from the converted code, at the same time trying to develop a conversion workflow. So we learned a lot from the prototypes, not just on the capabilities, but also in some limitations and the way that we were approaching the problem. So one thing that just popped up, it was we are having too many errors related to missing libraries and things like that. So we needed to definitely get a solution for that. Having a really short error list from the compiler was another issue. Like, you can't exactly know all the errors that you have or how to address all of them with just 6 or 8 errors or something like that. It just limits your ability to fix everything like class by class and things like that. And the way that we are working on the prototype, it was unstructured. It's like getting a class, converting, compiling, testing it, go back to it again. It's just not the way to go, especially when you have a big code base. Nope, it's just a blocker. And as Keshav already told, we have a good source code, and PMD rules, strict guidelines, coding guidelines helped us a lot, which means that we are already forbidding the usage of objects, for instance, and like we had a legacy code, that's true, and that is going to be problematic, but at the same time we had a really well-structured code base, which proved to be a good thing. But at the same time, there is some refactorings that we could do in the ActionScript side right from the beginning. And just some of examples that we had to deal with. One was this invalid variable scope, which happens when you define a variable inside a loop, and then you try to access it outside. ActionScript allows you to do this, but Haxe don't. So this was one of the first refactorings. Another one was related to switch statements, where we usually use mappings in the switch cases, and here we are forced to use constants and concrete values. We had to change all of that. And this one was a really nasty one, but it's not exactly a Haxe fault. It's more to export to JavaScript fault, because what happens when you don't have the constructor being the first line is that you will either have null errors by trying to access stuff that it's not created yet, or you will have properties that will get overridden by the late super constructor. And we had some few others, like explicit castles in XMLs, some edge cases on arrays and vectors, and therefore we needed to refactor it. So as I said, our first approach was just having the source code, feed it to the converter, get it converted, compile it, and do it over and over and over again, but this just didn't work. So we found some solutions, but before that, I'm going to introduce a terminology that we use so you guys get a better context of what are we talking. And this is the first one, Amok. Amok comes from the testing cases, and it's more or less the same, except it's an empty implementation, and therefore the dependencies of Amok are minimum, because there is nothing inside there except for the API signature. And they only have the ineritable API, which means no privates here, just the public and protected stuff. Everything else, it's removed. And as I said, it doesn't generate compile errors. And this is the most important thing that we need to keep from mocks. And finally, they are temporary, because at some point we're going to need to replace them with concrete implementation. This is I don't know if you guys can read it, but you'll see it. So here we have a typical class with imports, privates, and constructor and functions. And how does a mock from this class looks like? This. You see, the dependencies were just stripped down to the minimum. There is no implementation. It returns to the default value. So this doesn't generate conversion or compile errors, which is exactly what we wanted. And now I'm going to introduce our first conversion tool, the preparser. So to deal with this type of issues that we are facing to import, we're also having problems with global functions. You don't have global functions in Haxe. So we needed to somehow move them into a class. There was a lot of string replacements that we also need to do, not just strings, pattern replacements also, and some other stuff. I'm going to it. So the first two things that preparser does is mock generation. It generates mocks from our libraries, come to this later, and it also generates mocks from our code base. And this is the global function changing that I was talking about. We have here two global ActionScript functions that are going to be converted into a static class, be used there. And same time, stripping imports that they won't exist in Haxe at all by several reasons. Replace strings patterns, converts namespaces, handles paths annotation. We'll deal with this later. And this is the most important one. Fix private name collisions for methods, constants, and variables. One problem of having well-structured code in ActionScript means that you're going to use a lot of private methods. And as you know, Haxe doesn't have a real private. When you subclass another class, you'll inherit the private methods, which means in a simple case like this, we have two classes, one extends the other one, and they have exactly the same method name. They are different methods, but this will not be converted or generate valid compilation because we're going to have a naming error here. So one thing that preparser does is automatically it will detect these cases, and it will rename these methods, so we don't have to worry about them and things like that. So from that original workflow that we had, like the source code, converter, and compiler, we now added a bit of complexity. So this first part on top, it's only to deal with our libraries. So we are generating mocks from our libraries, all of them, which means when we're going to feed this to the compiler, there won't be any more missing classes, methods, and things like that. So we are done with classes for now. We won't have to deal with them at this point. And about the rest of the code, we just use, the only difference is this preparser source code, which is basically that string replacement and strippings and things like that. And this will be our alpha workflow, first one. So from this point, it will make sense to move to the converter. That, as Keshav said, we were using the Haxe Foundation converter. It needed some work, but it was like where we should go next, but we had some concerns related to it. So first of them, it was this error cascading issue. Like you have an error in one class, you use it in another one, alt usage of that class will generate another error. Second one was like obvious and related to the third one, because you could, as you have a small error list, you can't get the alt errors from one class. There is also this error relationship issue, and basically, how the hell are we going to attack this? Are we going to get some plan? Do we even know how many errors we have after all? So after all these concerns, we start thinking about it and decided that we need something. We need to get a plan and answer these questions before attacking the conversion. So we came with this new tool, which is called mocked compilation. And as an answer to the first two points that we had here, like getting to not having the error cascading and getting the errors from one class, the solution is using mocks. So basically, we are going to compile every single class in isolation by using mocks. And because mocks don't generate errors and have minimum dependencies, this will just do it. And this thing of compiling in isolation is what we call a mocked environment. If we pick that single thing of compiling in isolation, use automation and take it to the extreme, you get something like this. So you basically have all classes being compiled in isolation, and these results will then go into a central system that will compile all the reports. And with this, we'll be able to access things like list of all no errors. They'll be grouped by type. They'll have a they'll be sorted by count as well. We'll have the list of most problematic classes. We'll have errors grouped by patterns that we define and by patterns that the system detects. We'll have finally a global error count. And by us manually looking at these lists, we'll always also be able to fix error relationships. Like if you fix one error, you won't have another one. There is this type of situations. And we'll get some error fixing priority finally, which also means that now we can plan and estimate the effort of converting everything. So let's update again the workflow. This was what we had after the preparser, and now let's get complex. As I said in the pre-parser part, we are generating mocks from our source code. They'll be also fed into the converter, which will generate converted mocks. We have our converted external libs that we have done in the pre-parser step. And we have all these classes being compiled in isolation and reporting back in the mocked compilation. Just to give you a small example of the output of the mocked compilation. At this time, we were compiling just about 4K classes, and we just have 30,000 errors. It's just some. We had much worse. We started with 80,000 or 100,000 or something like that. But we have a lot of cool stuff here. As you can see, we have finally the error counts, and we know this looks a bit complex, but it's quite simple. It's basically telling us that there is no this isolated error. The grouping of the errors show us that most errors have an average of 11 errors or something like that for a group. And if you look at the top, just by looking at it, we know if we fix this class, we fix 50,000 errors. Which seems to, I mean, instead of just going pick file by file, I would say that's definitely a good way to start. And at the same time, we also have the top 10 of the types of errors. So when we're going to improve the converter, these guys will be the first ones, because they will provide the best output and decrease the error number. And we also went into the Haxe compiler to check the error codes, and we are also using them here. But this thing will basically define our plan on what we need to improve and what we need to attack in the converter. So now, finally, we're going to improve the converter. As I said, we're using the Haxe Foundation converter as base, and then we extended it. And the converter itself, by default, like as it is, it has a very good Haxe code quality output, which is awesome, because as Keshav said, we plan at some point to move to Haxe. So we don't need like mumbo jumbo code or spaghetti code or something like that. No, we want well-structured code and classes. So this is very important. It is fast, especially if you use the C++ version. Don't use the Neko version. Compile it to C++ and use the C++ version. It can resolve local type issues, variables and methods that you have in your class. You will know exactly how to deal with the types. It's highly configurable to XML, which is also quite good. And yeah, it's open source. You can extend it, manipulate it however you want. This is definitely one of the biggest points of it. Now, on the bad points, it's stateless. So it converts one class and completely forgets about it. It doesn't retain any knowledge or anything. It just gets it, converts it, and next. So, yeah. As I said, goes class by class basis and can't resolve dependency issues. So if you are using imports and things like that, he has no idea. He doesn't care and doesn't know. And therefore, you're going to have a lot of headache on this point. So let's see just some minor issues that we have before the improvements. This is, we have the ActionScript version and converted version. We have a typical into bool issue where you have an integer. Here, this winner bit, it's an integer. And here we have a Boolean. And because this is a Boolean expression, is it wants to have evaluate into bool, and it just doesn't allow you to do that. Same example, this time with an array. We have an array here, and we have an integer. It's a Boolean expression. It will blame again. Float to int, this is actually more OpenFL issue, because while in ActionScript it allows you to have a number here, in OpenFL this must be an integer, and the result of the expression is a float. So problems again. Bitmap to data or object to data, like if you just assert it, this is perfectly fine in ActionScript, but it won't allow you to do this in Haxe. And the conditional calling, as we use this a lot in our code. If it's basically the same as saying if this, just do this. But the result is a Boolean there, so nope, we're going to have issues there. So we definitely went to improve it. And we started by reading and storing the abstract syntax tree of all the converted classes, the Flash API, and our dependencies API. And with this, we created the type checker. So this type checker will basically allows us in any part of the converter to know anything about any variable, method, parameter, whatever. We know exactly what type to use there because we are using this huge dictionary and class to just have all the mappings and everything that will just read by the imports that we use. So after the improvements, we have really small changes. Now we have the previous Haxe version and the one that we use, the previous converter version and the one that you're using now. As you see, for these cases, it detects it's an integer. It just adds the rest of the missing Boolean expression. Here, the same thing. In the object part, he checks the object against null, and in the integer, just in this case, it adds greater than 0. And here is using the compat expressions to force a parseInt on the result. And finally, here it's exactly as in the Boolean. We check against the nullability of the object. And finally, the conditional calling itself, it's converted to a pure if statement. And all these things without touching the source code. That's exactly what we wanted. So, before we have this stateless converter, and now we have something which is not stateless. So as I said, we inject the Flash API, game call, dependencies API, create the abstract syntax trees, and use the type checker to convert everything, not isolated or in stateless set, but in everything. And we didn't stop here. You guys are aware that the converter itself has some compatibility classes to help with the Flash API, but yeah, there's also a lot of stuff that we can do there. So we improved them and extended them by adding missing functions from ActionScript tree, adding vector array, string extensions, functions that were missing there, type abstracts for some cases that were dropped later, but in the beginning at that time we needed them, and a lot of other new stuff. So after this, we have the converter workflow to be updated, that basically we just start injecting the Flash API converter and the external libmux. And this will be our final first workflow that we're going to use. And with this, we basically achieved the milestone objectives. We're going to have 0 compilation errors from the converted code and develop a workflow that actually works. I will pass to Nenad now that will continue.
Yeah, hello, I'm Nenad, and I'm gonna talk about further evolution of the workflow. So we had 0 compilation errors. We achieved automation that we didn't even hope for in the beginning, and we are pretty happy about it, but we couldn't play the game. We couldn't write the game. Why? Because we used mocks, so most of the libraries were basically empty, just API definition, so nothing was working actually. We just have 0 compilation errors. This is one point where we now need to downgrade basically our workflow, and it was actually too complex, and not because of the complexity, but because some parts are not needed anymore. We reached this zero compilation point, and we didn't need some parts, so it's good to have it simplified. We needed to port the core libraries that will allow us to have some kind of runnables, visible runnables. And yeah, because we were very happy about the automation, that was even more than we expected at the beginning. We said, okay, now it's time to find a way how to fix the runtime issues. And yeah, we had to establish a change process to change the hex code somehow to make it working. And yeah, we wanted to have the city running. That's the basically main goal of this milestone. So this was, you already seen, this was the latest workflow that we had so far. And yeah, because mock compilation basically just helped us to improve the converter to bring it to the point that we have zero compilation error, so we don't need it anymore. And we are coming up to this state. We just dropped the mock compilation completely, and now we run the source code through preparser, preparsed ActionScript code through converter, resolve the type issues there, get the hex converted code, and then compile it to JavaScript. At this point, we already started converting some core libraries that we used. Unfortunately, we use RobotLex 1.5, so 2.0 is already converted, and it's in Hex repository, but we had to convert the RobotLex 1.5 for ourselves. So we did that. We did our internal Snake ISO engine. We call it Snake. I mean, we have also plenty of internal libraries that we had to convert. But we still use, and we still now use some of the libraries that are still mocks, but we convert them as we need, as we go further with the porting process. Yeah, at this point, we had the core libraries converted, but the game is still not working. Yeah, then we had the runtime issues that we need to address. And yeah, we had to have some kind of change process. So what we decided is that we will create a Hex repository, which will look like this. This is very similar module that is, as we use for our ActionScript repository. So we have the spoiled it. Come on. Okay, what's going on? Okay, we have the master branch. This is a stable one. We have this special branch. It's called conversion branch, where only the converter pushes, so no other branch is merged back to it. And we have develop branch. From this branch, which branch out feature branch, we fix the runtime issues, then merge back to develop, and then for some point merge develop to master. We were pushing from time to time to conversion branch because we were improving the converter, and also new features are coming into ActionScript code, so we wanted them to have them converted as well. And then we but what happened actually, this model also have several fundamental flaws that basically prove that it's a wrong decision. What were the flaws on this model is that first, we decided to make a compromise and to have this manual merge step. We had this manual merge step to merge conversion changes to develop. But because we are very happy for the conversion automation, we decided, okay, this is just one step. We can do it manually. But what happened actually, because we never merged to this branch, because we will just delegate or just shift the merge conflicts from this point to the point where the conversion workflow pushes to the conversion branch, we experienced a lot of merge conflicts where, for instance, the conversion code has a merge conflict with the feature branch fix. And what was even worse is because we never push back to the conversion. Once you have a merge conflict, you have it always. And whenever you want to merge this branch back to feature, to the develop branch, we always had to resolve the same merge conflicts, basically, which was too painful. Another thing was that also other developers were doing feature development and ActionScript, and sometimes they were not too careful about these language differences. For instance, some of them were mentioned already, switch cases or using variable before it's basically declared or something. And then we also, when we do the conversion, and then we had to also fix these things as well in the ActionScript code. It was like kind of painful to work with this kind of workflow. And the other very, very important thing that happened here is that somehow, as we were doing changes in the hex code, the hex code started drifting away from ActionScript 3 code. But the very, 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 very good thing was that we realized this pretty soon. So we haven't gone too much into the porting process when we realized that this basically is not working for us. But we reached our objectives with this workflow. We simplified the conversion process, we ported the core libraries, established the change process. We had the city running, but it was too painful to work with it. So we decided to step back and yeah, go to the next milestone, which is going for full automation. To have the full automation, the requirement was to have the continuous conversion, basically convert everywhere whenever you like, and you have the runnable JavaScript, basically HTML5 game. And for this thing, we didn't need change process because the changes were not going to go into the hex code anyways. So what we did, basically we dropped the hex repository. And basically we don't store anything apart of the ActionScript source code, which is already stored and it's used for our ActionScript client. So yeah, we just don't store any intermediate artifacts basically. But yeah, we still have runtime issues that have been fixed in hex code. Now we cannot change the hex code, so we have to fix the runtime's errors anyhow. So which are the places? So where are we fixing this? Is in ActionScript 3 code actually, pre-parser and the converter basically. And now the question is how we do it safely, so we don't break the ActionScript code, but we have them fixed in Hex. Therefore, we have some more terminology. So we introduced a concept called annotation. It's quite known one. What is annotation is basically a comment in ActionScript 3 code which hints our tools, pre-parser or converter, to take certain decision. The second thing is it doesn't affect the ActionScript 3 code at all. And we have, actually we currently use 3 of them. We had plans for more, but the thing is that this is an exception that shouldn't happen often to like have this kind of exceptional changes in ActionScript 3 code to make it working in Hex. And so what are these are like examples of the hints, like this one. It's called Hex Type. We instruct the converter to convert dictionary type to this generic dictionary type. I expect questions later, I can answer. We use generic dictionary, yeah, and just strictly type the dictionary here. This is suppress annotation, means that this code should be ignored, so it's not converted at all. And we have inject, which basically injects a line of code. It's super, we should avoid it as much as possible. We just use it adding RTTI types, annotation, hex annotations on few classes, because for some of them we need runtime type information. But it's currently used, I think, only for this thing, not the other things. Another thing is a sealed class. Sealed class is more like adapter or something. It's a class that is never converted. We provide manually hex implementation of this class. This class has the same API as Hex, as ActionScript 3 class, but different implementation. So some things that work in ActionScript doesn't work in Hex, so we have to provide different implementation for the same API. And it stores separate libraries, so it's not in this kind of hex code that we drop on every run of the conversion process. And this is also an exception case, and so we have just few of these classes, basically infrastructure classes. It's not something that we use for the game directly. I have one example of it. You don't see this, I guess, but that's actually good because this is a huge class. It's core MD5, core lib MD5. This is like the whole MD5 algorithm here, and in Haxe you have just one line. So that's like just perfect example of a sealed class. Yeah, but we also need to change how we use assets. In the first workflow, when we actually had the Haxe repository, we used separate assets. So we used PNGs for texture atlases, while in ActionScript we use ATFs, and for SVF asset bundles in ActionScript we use texture atlas asset bundles in Haxe. Therefore, we decided to use the same formats everywhere. We needed to do some small refactorings in ActionScript to be able to use these ones. This kind of asset loading stuff are pretty well separated in our code, so it was not like super big effort to refactor this. It's like just 1 or 2 classes basically. And we use texture atlas basically in both clients. Yeah, we contributed ATF support to OpenFL, like without internal JPEG XR compression, because it was like difficult to implement that, but we add additional external gzip compression to our assets, so we load them as a jzips and then decompress them and use them in both clients the same. And this is our current workflow. Basically, if this is the versions of ActionScript code, we just run them through the automated conversion, we get runnable HTML5 clients. The conversion workflow is integrated to our continuous integration now, so we run the conversion on every pull request on ActionScript 3 repository, so we can immediately validate if the changes in the ActionScript 3 break the conversion. This is not something that happens often, that ActionScript 3 pull requests fail, because the workflow at this point is quite robust and it's working very well for us. We deploy HTML5 client nightly now already, and we have the same UI automation test that we are running on ActionScript 3. That's how we track the runtime errors now. We run on our HTML5 client. Yeah, what is the current state? So this is not obviously a postmortem because we are not done yet with the port, but we are, yeah, we were, it's kind of this position like 10 months ago or something, or maybe 1 year ago. Yeah, there are so many options. We were super inexperienced in Haxe, and yeah, we didn't know exactly how to, where to go, but with kind of structured approach, we are kind of more like this now. The end is kind of near. Yeah, if we look back on the goals that we set to ourselves, like at the beginning, we can clearly see that we don't have feature freeze. Basically, all the ActionScript features that we have at this very moment, they are also in HTML5 clients. No game rewriting. Prefer automation. I guess we even overdo this because we didn't believe at the first moment that we can have even the conversion to be fully automated. We also expect to have automation to a certain extent and then do some manual changes there, but we actually did it even more than we expected. And that was really nice achievement, which allow us to lots of other things later. Doing a reasonable amount of time, yes, work in progress. We still think the amount of time is reasonable. We are pretty close to finishing it. Good risk management, definitely. We had this kind of structural approach, which we get it by having this all kind of these tools that we could track all the errors and so on, and prioritize things. So this definitely was fulfilled. Good performance. Well, we are okay. I mean, the performance is good of the game, definitely. It's not very different than ActionScript 1, but the other thing is that we didn't pay at this moment too much attention on optimization and on performance. We did some quick wins, as Andre mentioned, because the original S operator conversion of the S3HX converter was that try cast, which generated a lot of errors, and the catching errors and generating errors is quite slow, and we just optimize it so it get a lot of performance just by optimizing the S operator, so conversion. So it was really nice, but didn't have like really deep look into performance. So I mentioned a few times runtime issues. So what kind of runtime issues we have? There are certain types of runtime issues. Some of them are like OpenFL features. I mean, OpenFL either doesn't support something or it's not, it does not behave as ActionScript would behave. But yeah, we contributed a lot to the OpenFL as well, and because we're using DOM rendering, it seemed that DOM rendering is a little bit more neglected comparing to other targets. There are some issues, but this is very important. OpenFL is really great library. I mean, I recommend and encourage everyone to use it if they want to move out from Flash. It's really good one. A lot of support, a lot of good guys working on it, and it's getting better day by day, and it's really good. Of course, it's not like one-to-one mapping from Flash, but it's pretty close to it, and they're really good at it. So yeah, kudos to these guys. Yeah, type issues. For instance, as I already asked today, it's if you have array and if you have dynamic type, like to an element, but and you want to access, but the array actually contains some proper type, and if that proper type has a property that you want to access, then the compiler does not know how to convert that property access into JavaScript if it does not know the containing object type. So it has to add this get underscore or set underscore to the properties to access it. And this is kind of issue which are very easy to solve. Just add this hex type annotation, and that's basically it, immediately solvable. And some reflection access could be problematic because the converter itself doesn't know how to resolve the type of the property, which is basically decided on runtime. So we find a way how to resolve these issues, basically how we go. And yeah, SVF assets bundles, we changed most of them. We have one or two left because they are in the modules that we haven't ported yet. What is the current state of the game is that we have these core modules running: city, research, campaign map, and battle module. So yeah, this is already running. We need to port the remaining two guild versus multiplayer modules, basically guild versus guild and guild expeditions. We need to do detailed tests, performance tests and optimization, obviously, and yeah, polishing at the end. And we expect it to go live with HTML5 client at the beginning of the next year. And now I try to show you a demo. It's a short one, but a sweet one. Okay, it's kind of awkward. Yeah. Let's go back. Okay, this is the folder where normally the JavaScript client is deployed. So we can try to load the what? What is this? Okay. Yeah. Okay, but I don't want this player. Wait, it's a little bit complicated. I mean, it doesn't matter actually. The city. Okay, just want to show you a better city. That's what I'm trying to do now. Okay, I just show a different thing. Okay. This is unfortunate, but okay. You've seen that there is no JavaScript client here, okay? And I go just in the okay. Let me clear first this. If I run, this is what happens when you have presentation. Yeah, I tested it 1,000 times. So now the pre-parser is running. These are the sealed classes. You can see this. Yeah, now it will continue to give you, it will show a small report. Yeah, the report is actually above. These are the stats. How many injected? How many inject we use annotations? How many suppress? How many sealed classes? How many hex type annotations we use? The converter is converting now the code. Now the compilation starts, and we should be able in a minute or a little bit less than a minute see the ActionScript client in the folder here. Come on. Okay, it's there. So it's, you have to trust me, it's working. Yeah. Thank you. I invite the other presenters for a Q&A session. So if you have questions, please feel free to answer. Oh, wait, I need to go here.
Why did you guys go with the DOM rendering option?
Why? Sorry?
Why did you opt for a DOM rendering option?
Because in our ActionScript game, the UI is rendered on Flash display list, and we have the city, which is basically rendered on Starling, on like with hardware acceleration, and we wanted to have the same thing in JavaScript version. So we use DOM for UI elements, and then the city is rendered on Starling, basically. Yes, I mean, the thing is that we ported also a lot of other libraries that haven't been ported. We also have this converter thingy. We would like to contribute, but we need time to just like make them ready for the for contribution. The thing, I mean, I also think that the company also doesn't have anything against contributing, and they actually encourage that. So it is really likely, if management allows us to spend time on that, to have them like push to the Hex repo. Any other questions? Yeah.
So are you guys planning on eventually just switching over and just writing in Hex, or do you plan on just eventually?
I mean, that's really interesting question. The thing is that this now like completely automated. We have options. The Hex code is perfect one. It's like almost as mirror code to ActionScript. It's very clean. We can also start writing Hex. We can also use ActionScript. The other question to Andre was, I think, why we don't export like Flash version from Hex, because we don't need. We have already ActionScript. We use the ActionScript code. We can compile it directly to Swift. Why we would like do this kind of, it's a little bit overkill to use the ActionScript to convert to Hex and then compile it to SVF.
To what extent do you attribute your success to the strict coding conventions that you're using on the ActionScript code base? Like if you were a little bit more lax, would you be a little bit more, would you have a little bit more trouble or a lot more trouble performing this algorithm?
I don't know, because we haven't had the other situation. The thing is that, yeah, we have strict typing. So basically every variable that is ever declared in our ActionScript 3 code has to have a type, because otherwise the PMD rule will fail and so on. You always have to have commas at the end, blah, 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 and so on. The thing is that it's important to have type, because when the converter reads the class, it creates the ActionScript 3 and it attributes the type to that variable. And then when I search, I mean, when the converter search through the actions abstract syntax tree to find to basically resolve that variable to particular type and then apply the type information, then it would be actually necessary to have the type. Otherwise, it would know. I mean, it will still work. It will convert it, but then you might have compilation issues. I mean, yeah, I mean, the other thing is, he just mentioned, you can also add annotation if you know the type and it's not there. Then the converter will also through the annotation add a particular type. Yes, please.
Simply, if you have a problem in the ActionScript code and you fix it with an annotation or something,
Mm.
you know that's
Mm.
going to be a simple, safe change.
Mm.
If you turn out that you have a problem in the converter and you make a change in the converter, how
Mhm.
do you know what changes you might have introduced? Right? If you're trying to fix one problem in the converted code,
Mhm.
you modify the converter. How do you know you don't introduce problems elsewhere in the converted code when you do that?
I don't know if I got the question right. How do?
When you make the change to the converter itself,
Yes.
right? How do you know what potential issues you might be introducing? Right, you're obviously making a change because you see a generated piece of the code is wrong,
Okay.
right? And you know if you make that change, you get the correct code.
Mm-hmm.
But how do you know what impacts you might be having elsewhere in the rest of the code base by making that change?
I mean, first we have tests. I mean, on the converter, we test the expressions. Are they converted properly? The second thing is that compiler will complain. Yeah. Yeah, this is from the runtime, but yeah.
So you said you're moving away from Swift assets.
Yes.
What's the particular reason?
Yeah, I expected this question actually. The thing is that OpenFL also supports SVF, right? The thing is that we load SVFs on a runtime, basically. That's first thing. And the second thing, we have SVFs with 500 objects. So if you want to use it through OpenFL, then you have to load every single object with the URL request, basically. And we don't want that. We just put them all in. These are basically very small. There are icons, for instance, but it's much more optimal if you have it in one texture atlas and just load it as a texture atlas. Any other question?
You mentioned that Hex doesn't have global functions.
Yeah.
You can actually do that in Hex if you know how, because you can import static fields, static functions. So if you write at the top of your file import, I don't know, this print or something, you can throughout the file just use print and it's gonna work. And that, together with the feature import Ajax, which we introduced, I think, in 3.4, if you put the file imports.ajax at the root of your source directory, and whatever imports you put in there are gonna be placed in every file in the directory. So you can use an imports.ajax, which does import your static that you want to import, and that basically gives you a global function.
Okay, thanks for the hint. I can, yeah, we might use that. That's, I mean, it's really good. But the thing is that static functions was something that we fixed first, which was like 1 year ago, and we have no Hex experience whatsoever. And yeah, thanks a lot. Yeah, yeah, cool. Thanks. Yeah. Any other questions, maybe? Yeah. Then thank you. Yeah, if you we're gonna be around, so if you have also questions, you can just approach us and ask.